Alright, hi everyone. Let's continue with our data structures and algorithm series. In our previous video, we implemented the insert method, and today we are going to implement remove method for our linked list. This method works by removing a node from the linked list at a specific position. For example, let's say this is my singly linked list and I have to remove a node at index 2. Now if we look at this singly linked list, the node at index 2 is node 7. Now in order to remove this node, what we need to do is simply remove the reference of this node, right? Look at this solution. First we need to do is access the node at index -1. Right now the required index is 2, so index -1 will be 1, right? So what we will do, we will simply remove the reference of node 7 from node 5, and instead of pointing to node 7, 5 will directly point to node 9, and that's how node 7 will be removed. So in short we can say no reference, no node, and that's how we remove a node from the linked list at a specific position. Simple, right? Now let's look at the pseudocode and try to implement this in JavaScript. Alright, so this remove method will accept a parameter called index. This index will tell us from which position we have to remove the node, and the first step is if the index is less than 0 or greater than the length, then return undefined, which is just a validation that we did in our insert method also. So let's implement this one. This is our singly linked list that we implemented in our previous videos. You can check out that. I will implement the remove method here. So remove, it will accept an index, right? And then we have to do our validation. So if index is smaller than 0 or index is greater than equal to this dot length, which is the length of your linked list, if this case happens, then we will return undefined. Alright, and the second step is if the index is same as the length -1, which means this index is pointing to the last node, then we can simply call the pop method that we implemented in our previous videos. You can find the links in description. But in short, this method basically makes the last second node as your new tail and makes it to point to null so that the last node can be removed, right? Let's implement this one. I will put another if condition here. If index is equals to this dot length, then we will call this dot pop. This should be this dot length -1. Alright, let's look at the next step. If the index is 0, then make the second node as the new head, meaning we have to remove the first node of our linked list because the index is 0 and the 0th index is the head node of the linked list. So we have to remove that head node and make the second node as the new head. This process is also called shifting. You must have done same thing with arrays as well, where you have removed the first element of the array, and there is a method called array.shift. So let's implement this shift method and then we will use it in our remove method. I will create the shift method here, and first of all we will do the same thing, handling the basic case like if your linked list does not have any node, then we cannot remove anything, right? So we have to return undefined for that. So I will create a if condition here. If we do not have head node in our linked list, which means the list is empty, then we will return undefined. Now in case your linked list has some nodes, then we will store the head in a temp variable. Let temp equals to this dot head, and then we will make the second node as our new head. We have to do this dot head equals temp dot next, right? And now since we have removed one node from our linked list, we have to reduce the length as well. So this dot length minus, and now if let's say the length becomes 0, then we will make sure the tail node points to null, right? Because temp.next, which is our second node, will anyways be null and head will already point to null, and we have to make sure tail also points to null in case we do not have any node in our linked list. And in the end we will simply return the removed node, that is the temp, right? So this is our shift method. If you have any confusion, you can ask in the comments. Alright, now we will utilize this shift method in our remove method. So if the index is 0, then we will call this shift method. Cool. Let's check the next step now. The next step is, if the given index is pointing to a node that exists in the middle of the linked list, then we have to access the node at index -1. The same thing which we did in the insert method, right? If you don't remember, then you can check out the insert method video. The link is available in description. And once we found the node at index -1, then we have to make sure this node points to next node. The same thing which we did here. We have to remove the node at index 2. So we access the node at index -1, which was node 5, right? And node 5 directly pointed to node 9, skipping the node 7. And that's how we removed the node at index 2. Same thing we have to implement now. So we will utilize the get method of our linked list to access the index -1 node. I will create a variable here, previous node. Let previous node, we will use this .get method and then pass index -1. This will give you the previous node, and then we will create another variable called removed node, which will be previous node dot next, right? And then we have to make sure that the previous node points to the next node of removed node, right? We are skipping the removed node here now. And once we skip the node, we have to reduce the length as well. And in the end, we will simply return the removed node. Alright, that was the pseudocode, and that's the implementation of remove method. Let's try this in console. First of all, I will log the linked list which we have created here. You can see we have 4 nodes right now. First, I will remove the node at index 0 to test the shift method, and we'll add a console log as well so that we can see it in our console. Alright, you can see we got our remove node, and that is with value 1. Let's log our updated list now. After removing the node at 0th index, this is our final result. The head is now pointing to node 2 and the length is also reduced. So our remove and shift method is working as expected. Now let's remove node at index 2. So I will just change the index here, we'll refresh the console, and now you can see the removed node is node 9, which is correct, and this is our updated linked list. 1 is pointing to 2 and 2 is pointing to 10. Node 9 is successfully removed. That's all for this one. And that was the last video on singly linked list. From the next one, we will be implementing doubly linked list and its methods like push, pop, remove, etc. So stay tuned for that, and thanks for watching.